Okay, we're going to start with the definition of a limit. The definition of a limit, if f of x becomes arbitrarily close to a unique number L as x approaches c from either side, then the limit of f of x as x approaches c is L. This is written as the limit as x approaches c of f of x equals L. So for today, we're just going to find the limit as x approaches some value from a graph or from a table. Okay, so for this graph right here, it asks what's the limit as x approaches 2 of f of x, where f of x is this graph. So I'm really trying to figure out what the y value is as x is approaching 2. Now the weird thing is I don't actually care what y equals to as x equals 2. It's what happens as it's approaching it. So I'm going to trace this graph. And I'm going to go towards the x equals 2 point, which is right around here. So if I come from this side, it looks like the y value is going to be 4. If I come from the opposite side, it also looks like the y value is going to be 4. Now, I don't actually care what's happening at the point. Sometimes there's no point there at all. But because the y value appears to be approaching 4 as x approaches 2, then the limit as x approaches 2 is 4. Okay, if I do 0, x is 0 is here, but I'm looking out here at the graph. But again, I'm not looking at the actual point. I don't care about the actual point. I care about what it looks like it's approaching. So if I come this way, it looks like the y value is approaching -2. If I came from the other direction, it also looks like the y value is -2. Let's try x is 1. X is 1 around here, but I don't care about the actual point. I want to know, does it look like it's approaching 1 from this way and this way? Yeah, the y value does look like it will equal to 1 in both directions. Okay, let's go ahead and look at the next graph to the side. And I'm going to do the same idea. Okay, as x is approaching 1, I want to see what the y value of the graph is doing. So x is 1 is here. So I'm going to go up here to this imaginary point. Remember, I don't actually care about this exact point. I care about what it looks like it's going to do as it comes from the left to the right. So it looks like the y value is going to equal to 2. Okay, now let me do the same thing at x equals 3. This is x equals 3. You can see at x equals 3, there's not actually a point there. I don't care that there's no point there, though. I just want to see what it appears to be approaching. So if I come from the right side, it looks like the y value will equal to 2. If it comes from the left side, it also looks like the y will equal 2, even though at x equals 3, there is actually no value there. The limit of x approaches 3 is still 2 because that's what it appears to be going towards. And then if I go to 4, it's going to be the same because this is a constant. So it still looks like y equals 2 and y equals 2 from both directions. Okay, let's look at some more interesting graphs. Okay, down here, I have the limit as x approaches 0 of f of x. Okay, remember, I don't actually care what it equals at 0, which is good because I can see that at 0, there's actually no values because there's 2 open circles. So let me just see what happens when I approach x equals 0 on the graph from both sides. Okay, if I come from the right side, it looks like the y is going to equal to 1. If I come from the left side, it looks like the y is going to equal to -1. You can't have two answers. There's only one answer. So in this case, in one direction, y equals 1. In the other direction, y equals -1. So in this case, the limit does not exist. And the abbreviation for does not exist is D and E. And you are welcome to use D and E. Okay, now let me look at -2. At x equals -2 is down here. I don't care about the actual point, but as I approach from the left and the right, it looks like the y value is going to be -1. And at x is -4, even though it's not on the graph, 1, 2, 3, 4, I can assume that it's going to stay constant and it will still equal to not 2, -1. Okay, so let's see. One more graph. This is g of x. Okay, the limit as x approaches -3. Now at -3, there's no value because there's an asymptote there. But again, I don't really care what is actually at -3. I want to see what it's heading towards. Okay, so at x is -3. If I come from the right side, it's going down forever. If I go on the left side, it's also going down forever. So there's a couple ways they describe this. Because it's going forever, sometimes they call it unbounded. Because it happens to be going down forever on both sides, sometimes they'll call it negative infinity, because both the y values are heading towards negative infinity on both sides of x equals -3. But either way, the limit does not exist because it is unbounded. Okay, let's do one more. As x approaches -1, so here's -1 right here. Okay, it looks like, what does that look like? Negative 0. Maybe 4 from the other direction. It also looks like the y value is maybe negative 0.4. So I'm going to estimate that it's about that, and that's a reasonable estimate. Now I'm going to estimate limits using a table. It's going to be the same idea. I'm going to approach the x value from the left and the right, and then see what it appears to be going towards. It doesn't matter what it actually equals at the value. So in this case, I want to see what happens as x approaches -4. So as x is approaching -4, I'm going here, here, here. Now the weird thing is, again, I don't care what actually happens at -4. I can see it's -4, -13, but I don't really care. I just want to know what happens when it gets close. Okay, as x is approaching -4, the y values, -14, -13.2, -13.02, they seem like they are approaching -13. If I come from the other side and I approach -4, so -3.5, -3.9, -3.99, and you should be getting closer and closer to -4 if this is a good table. The y values also appear to be approaching -13. So since they both appear to be approaching -13, then -13 is a reasonable estimate for the limit. Okay, I'm going to go ahead and go to g of x. The limit as x approaches 2 of g of x. They've given me a table again. And again, I don't care about x equals 2. What the actual answer is, it could be omitted from the table, and that would be maybe even less confusing. Okay, as x approaches 2 from both sides. So in the x direction, make sure the x's are going closer and closer to 2. So 1.5, 1.9, 1.99. The y value is 8.99, 8.1. Looks like it's going towards 8. Okay, let me check in the other direction. The 2.5, 2.1, I'm still approaching 2, but from the positive direction. And the y values are getting closer and closer to 8 as well. So it looks like the limit is 8. Okay, and again, I don't care what actually happens at 2. At 2, it actually is 2.5, but I don't care about that. Okay, one more. This is as x approaches -1 of f of x, and they didn't even tell me what happens at x equals -1, which is fine because there could be no value there, or it could be just there to confuse me. So let me make sure my x values are going closer and closer to -1. As they are, my y values are increasing and increasing. So it looks like it might be unbounded from the negative side. So maybe it's going towards positive infinity. Let's see if the other direction is doing the same. So as I approach -1, actually this is from the positive side. Let's see, the y values look like they're approaching maybe 2. Okay, so in this case, the limit does not exist. And there's a couple reasons why. The main reason why is because in one direction, the y value is approaching 2, and in the other direction, it's unbounded, so they do not match. Although technically, if it were unbounded, it would automatically not exist, but for a different reason. But in this case, it's because the two directions do not match.